I've got a cough and a little sneeze. Knife Bay's will be knows with ease. With my symptoms checked in just a sec, Knife Bay's runs a quick health check.
Hello Professor and everyone. Today I would like to present my mini project where I use Knife Bay classification to predict disease type using symptoms. I use Weka to build and evaluate the model. Firstly, I would like to introduce of my project. The goal is to classify a patient condition as either flu, cold, or allergy based on common symptoms. I use a small dataset with 20 patient records. Each patient has 5 symptoms: fever, headache, cough, body pain, and sneezing. Each symptom is encoded as binary values. 1 means the symptom is present and 0 means it is absent. This is the Bayes theorem. Knife Bay is a probabilistic machine learning algorithm that is based on Bayes theorem. It is widely used in classification tests. The Bayes theorem, which tells us how to update a probability when I get new evidence. In my case, the evidence is the patient's symptom and I want to update the probability of each disease based on that evidence. This formula is foundation of Knife Bay classification. This is the Knife Bay classification formula. This is used to calculate the probability of each disease by multiplying the probability of each symptom given that disease. I assume that the symptoms are independent. Then I select the disease with the highest probability. I started running my project using Weka. Firstly, I click the Explorer. I click the Open File and I choose the file, and after that I click the Classify that and I choose Knife Bay. After that I click the Stat. Here is the result of my project. In fever, most flu patients have fever. The results show 9 out of 10. Cold allergy usually did not have fevers. If a patient has fever equal to 1, the model will strongly guess the patient has flu. 90% of flu patients have fever. In headache, headache is slightly more common in flu, but not very clear because the results show 60% of flu patients had headache. In cough, cough is very strong for flu because the data show 9 out of 10 flu patients had it. Cold is evenly split 50-50. Allergy almost never has cough. In body pain, flu is the only class with strong body pain. Allergy and cold usually do not have body pain. Is another symptom that supports flu prediction. 80% of flu patients had it. In sneezing, allergy patients usually sneeze. The results show 8 out of 8. Sneezing is rare in flu. Only 1 out of 10. Cold is 50-50. Sneezing is good signal for allergy. When a new patient shows certain symptoms, I will look at the condition probability for each disease and predict the most likely one. This is the summary of result. This is total 20 patient cases. The model correctly predicted something. Given as an accuracy of 85%, which is good for a small data set, the kappa value is 0.77, showing that the model performs much better than random guessing. The F1 score is a metric that helps evaluate the accuracy of a classification model. It combines two important metrics: Precision. How many of the predicted positives are accurately correct? Recall how many accurate positives the model successfully caught. The F1 score varies precision and recall. If either is true, the F1 score will also be low. In my case, for the core class, the F1 score is about 0.73. 0.73 means that the model did a decent job. But in some cases, the ROC area tells us how well the model separated the Z classes. A score close to 1.0 means the model is very accurate when making predictions. For example, flu has an ROC 1.0, which means the model can perfectly tell flu apart from cold and allergy. Even for allergy and cold, the score are around 0.85, which is still very strong. In confusion matrix, first row is allergy. 5 allergy cases were correctly predicted as allergy. 1 was incorrectly predicted as cold. 0 were misclassified as flu. That's why the accuracy is 83%. Only one mistake confusing allergy with cold in row B. And 4 cold cases were correctly classified. 2 were wrongly predicted as allergy. 0 misclassified as flu. That's why the accuracy is 66.7%. In flu, 8 out of 8 flu cases were perfectly classified, no error at all. That's why the model had 100% accuracy for flu. In conclusion, the naive model worked very well on this small medical data set, where we predict disease like flu, cold, allergy based on 5 symptoms. It achieved high accuracy and perfect prediction for flu. This shows that naive is very interpretable, easy to train, and still powerful. That is important for quick decision in real-world setting. And also it can help support smarter, faster decision in healthcare. Thank you for listening.